Welcome to Probability and Statistics. In this lecture video, we're gonna talk about how we can estimate the population proportions. Alright, so to construct an interval confidence interval for population proportion, it is just gonna be just like estimating the population means, where our population proportion P, our true percentage, okay, is going to be the P hat, which is going to be our point estimate, minus the margin of error, and the other interval, the other confidence interval, will be our P hat plus the margin of error. So this is just going to be just like estimate the population mean. All right, very much just like it. Alright, your margin of error, okay, on the formula sheet, you should see the z sub alpha over 2 times the square root of p hat. Okay, make sure you see this. If you want to do this by hand, make sure you understand that the margin of error is using, okay, z interval. It's going to be using our z-score times the p hat times the q hat. 1 minus p hat would be called the q hat divided by n inside the square root. Okay, so I got a lot of students get confused. They thought this is a p. Okay, this is actually p hat inside this formula. So to construct our confidence interval by hand, all right, our point estimate p hat is going to be eventually equal to the population proportion p. Find the critical value z sub alpha over 2, and we have our lower bound and the upper bound. Alright, now to construct a confidence interval using calculators, we're gonna go back to the same place we done before, stat, highlight the word test, but this time, okay, we're gonna use something called the 1 proportion z interval. So we scroll down a little bit. 1 proportion z interval. So to estimate the population mean, we use the z interval and the t interval. The difference between z and t, once again, is z is where I got to type in population standard deviation. T interval is where I do not know the population proportion. Excuse me, the population standard deviation. So we will actually use a t interval where we will type in the sample standard deviation. Alright, so this is real easy. We gotta know what x is, okay, the people with the same characteristics, sample size, and our confidence interval. Alright, I'm gonna show you an example, okay, real quick. For example, the State Education Commission wants to estimate the fraction of 10th grade students that have reading skill at or below the 8th grade level. Okay, so when they say the word fraction, which we know we can turn into decimal, then turn into our percentage. Suppose a sample of 991 10th graders is drawn. Of the students sampled, 823 read above the 8th grade level. Alright, so my n, my sample size n, is going to be 991. Alright, 823 read above the 8th grade level. Estimate the proportion of the 10th grader. So you don't hear the word mean, so here we're going to start hearing the word proportion. Alright, estimate the proportion 10th grader reading at or below. Here's a tricky part right here. We want to find the proportion reading at or below the 8th grade level. 823 is reading above it. So how many people is not reading above it? So the number of students that's not reading above it, that would be 991 minus 823. So 168 does not read of at or below. Excuse me, 823. 168 read at or below. Alright, so that tells me that my p hat, okay, will be 168 over 991. So that tells me that our population proportion P, this is our P hat, our point estimate. Eventually, our point estimate P hat is going to be eventually becomes my population proportion P. Now, if we do this in the calculator, we don't need to know this percentage right now because I don't need to type. I just need to type it in. But just to show you in here, if I would divide it, that tell me about almost 17% read at or below the 8th grade level. Okay, so this 17% is my best point estimate that we can actually use. Alright, let's put in our calculator. Stat, highlight the word test, choose one proportion z interval. Okay, not number 5. Number 5 is one proportion z test. When we are constructing our confidence interval. Alright, the number of students read at or below, sample size 991. You want me construct, oh, this one does not say construct a confidence interval, so actually, sorry about that, actually this will be my answer right here. So round to 3 decimal place, that will be 0.170. It doesn't say construct a confidence interval yet. The second part does. Alright. Step 2 of 2 is saying construct a 99% confidence interval. So let me go back to this. 99% confidence interval. Calculate. Alright. So my lower bound, round to 3 decimal place. My lower bound will be 0.139. My upper bound 0.200. .139. About 13.9%, my upper bound. 0.200. So what that tell me is, if I would draw my normal curve, they tell me that my true population proportion P, okay, the percent of the students that read at or below 8th grade level is about almost 14% all the way to about 20%. So the true population proportion P is somewhere in the middle. My P hat, my sample proportion P, show me that it's about at 0.17. Okay, but the true proportion is somewhere in between these two numbers, lower bound and upper bound. Alright, let's try it again, okay? I think these problems are divided into 2 steps. The next example, FBI wanted to determine the effectiveness of their 10 most wanted list. To do so, they need to find out the fraction of people who appear on the list that are actually caught. So suppose a sample N of 306 suspect the criminal is strong. Of these, 100 are captured. So using the data, estimate the proportion of people who are caught. Okay, so 100 are caught. The problem wants me to find out how many are actually caught. So my X, okay, number of people with the same characteristic, which is the characteristic is being caught, which is 100. Alright, so our sample proportion is 100 out of 306. which I know that eventually will become my population proportion P, 3 decimal place. So that's about 0.327. Okay, almost 32.7%. Okay, that being caught. So this is my best point estimate. So now we need to construct an 85% confidence interval. So real easy. Stat. What is the true percentage? 1 proportion z interval. X is 100. Sample size 306. Construct a point. 85% confidence level. So my lower bound is about 0.288. My upper bound 0.365. About 0.288. My upper 0.365. So that tells me that my true population proportion P, the percent of criminal being caught on the top 10 most wanted list, is the true population proportion is from 0.288 to 0.365. It's somewhere in the middle. Okay, so just like the estimate the population mean, okay, we use our point estimate to construct this confidence level. Now, as you can see, every time, and this is real neat. I never done this before, but I'm going to show you here. Okay, these two upper and lower bound come from 85%. So if I would increase my percentage, so that means I'm making, see right now, my confidence level from 0.288 to 0.365 is within 85% confidence level. Alright, so now what happened if I would increase? If I would increase to a 90%, okay, it becomes 0.282 to 0.371. So my number, my lower and upper bound started to change when I begin to increase. So what that's saying is I'm increasing my margin of error as well. Okay, the wider, basically what it's saying is the wider the confidence interval, okay, the more of margin of error exists. So imagine I take up to 0.99, 99% confidence level. Okay, 0.5257. This number getting smaller and smaller. The yellow one getting larger and larger. So once I increased, okay, my confidence interval, I'm actually if I'm widening the confidence interval, I'm increasing the margin of error. Okay, because remember, when you do it by hand, part of it is finding the critical value z, the zeta alpha over 2. Okay, so once that zeta alpha over 2 times, okay, your p hat and q hat doesn't really change. So once the critical value change, alright, oh sorry, this is actually p hat, just realized that p hat doesn't change, okay, q hat doesn't change, sample size doesn't change. So there are certain value doesn't change when you do it by hand, but when you increase the confidence level, your zeta alpha over 2 will begin to change. So that actually make these margin error, okay, increase as well. Alright. I'm going to do this with you real quick. Finding the minimum size for estimating the population proportion. Alright, so to know the minimum size required to estimating a population proportion, we're going to take the P, population proportion P, times the Q, times Z sub alpha over 2 divided by the margin of error. So just like we've done this before. Alright, gotta know the P. The State Education Commission wants to estimate a fraction of 10th grade students that have reading skill at or below the 8th grade level. In an early study, the population proportion was estimated at 0.22. So my population proportion P is at 0.22. So my 1 minus P over my Q got to be 0.78. Right, 100% minus 0.22. How large a sample will be required in order to estimate the fraction of the 10th grade reading at or below at the confidence level of 85%? So my C level is 0.85, and we want to control our margin of error at most 0.03. So my error need to be at most 0.03. So let me copy this formula real quick. Alright, so the only thing I'm missing so far, is my Z sub alpha over 2. So if I go to my formula sheet, Z sub alpha over 2, the critical value of Z sub alpha over 2 at 85% confidence level is 1.44. The critical value of Z is 1.44. So this is going to be 0.22 times 0.78 times parenthesis 1.44 divided by margin of error 0.03, whole thing squared. Alright, let's punch it in. Parenthesis 1.44 divided by 0.03, whole thing squared. So round to the nearest whole number, okay, up to the next integer. So that will be 396. So I need my sample size to be 396. Alright, for me to have at most 0.03 margin of error at 85% confidence level. Alright. So again, the 1.44 is Z sub alpha over 2. Okay, as you can recall, if I want to construct 85% confidence level, that means the area in between the confidence interval is going to be 0.85. So that leaves me with the two tails, 1 minus 0.85, okay, 0.15 for both tails together, divided by 2. Each area is 0.075. So if I want to find the critical values Z, we can do second distribute inverse norm, like I showed you before from chapter 6. Area to the left 0.075, comma 0, comma 1. So that's about negative 1.44. That will be this one. So the other one is positive 1.44. So your So your zeta alpha over 2 is 1.44. Okay, that's where this number come from. Alrighty. So this is how we construct the confidence interval for the population proportion P. So we use the 1 proportion Z interval. Okay. So when the problem says the word, fraction or percentages, when they start giving you percentage, that means they want you to estimate population, okay, proportion P. Alright, that will conclude this lecture video. Thank you for watching.